Problem 410 has 4 parts. The overall question or problem is asking for a time value of money using a financial calculator. If you have a financial calculator, feel free to use it, but we're going to use Excel to solve here. These questions are asking you to figure out, A, are you trying to solve for a present value or future value? And then once you make that determination, what is the solution for the present value or future value? A states an initial 500 compounded for 10 years at 6%. So what this tells you, the way the question's set up, an initial amount of 500 is a present value. So it's saying you have presently $500 growing at 6% for 10 years. So the goal is to find a future value. Part B is phrased the exact same way as A, with the exception that the 500 will be growing at 12% instead of 6%. So we can also easily infer that, well, this is also a future value. Part C says there's a present value of 500 due in 10 years at a 6% discount rate. And what this is really saying, if you read it clearly, the present value of 500 due in 10 years. So the 500 due in 10 years is a future value, and we're going to discount it at 6%. So we're going to try to find the present value since the future value is known. D is set up the same way, except the discount rate is higher. So now we've identified the goals. For A and B, we are trying to identify a future value, and for C and D, a present value. We'll say equal sign, future value. We know a rate is 6%. Number of periods is 10 years. There's not going to be any payments made over the 10-year period, so we'll just skip that. And there's a present value of 500. So we'll represent this as a cash outflow today with the expectation that we're going to get money flowing back in the future. So we see that the 500 growing at 6% for 10 years should have a future value of $895 and 42, possibly 43 cents. We'll then replicate for part B. The only difference is we're going to change our growth rate to 12%. We can take our formula before, drag down, and the only difference here is our rate, we're going to change from 6% to 12%. So we have the function FV, a rate of 12%, number of periods is 10 years. Payment is blank since we're not making any payments during that 10-year period. The present value we're saying is a negative 500 today. That is, if we deposit 500 today, we have a cash outflow of our wallet, 500. How much do we expect to get back in 10 years, growing at 12%? We see that the future value is going to be $1,552.90. For parts C and D, we're now trying to identify a present value. So we'll start out with equal sign PV to evoke the PV function. Our rate here is 6%. Number of periods is 10 years. There will be no payments made during the 10-year period, so we'll just leave payment blank. The future value is going to be 500. And we want to see what is the value, or the present value of 500 due in 10 years when the discount rate is 6%. We see that there is a present value of $279.19. We can also review this as a negative because it's actually due in 10 years. However, if we were buying this cash flow, we would also say, well, we'd be willing to pay $279.20 today. We can use the exact same formula. The only difference here is we're going to change the rate. So we're again invoking the present value function. We're going to make sure that the rate now is 12%. Number of periods is 10. There will be 0 payments made over the 10 years. And the future value will be a payment of 500, or present value of 500, or future value of 500. We'll change this from currency to number. And we can see that because the discount rate is larger, the present value is lower. We see it's $160.99. So hopefully that helps you understand setting up the question. We could also do this using the manual long form present value, future value. But I think it's probably a lot better that we get used to using these present value and future value functions. And in your workplace, you'll probably have more value added if you're familiar with using these functions.